Hello friends, this is one of the concept of fracture mechanics, that is stress function for mode 1 crack under biaxial stress. So here this one is a figure, the mode 1 crack under biaxial load. So here consider the mode 1 crack problem representing an infinite plate under biaxial stress, right? So here the relation is given: z is equal to sigma z divided by square root of z square minus a square, where z is equal to x plus iy. Since this is a theoretical part, I mean whole concept is of theory, so I just brief, and if you want you can make a note of this one so that you can reproduce it. This carries about 6 marks or 8 marks in your exam. So this solution is for mode 1 crack, and after that you can go for mode 2 and mode 3 using all these steps. So this is a general mode 1 problem. Okay, this figure is for general mode 1 problem. See here, an infinity where z tends to infinity, the result is sigma x sigma y is equal to sigma and tau xy is equal to 0. Why, I will tell you in the next page. On the crack surface, and on the crack surface here, sigma y tau xy is equal to 0. Okay, that is the boundary condition are satisfied. So if this tau xy shear and this thing tau y term, uh, tau xy and sigma y, if they are 0, then it will satisfy the boundary condition. Y means, yes, you consider the general problem figure 2 here. This general problem, the boundary conditions are not yet specified, that is why this occurs. And next, it is more convenient to convert to a coordinate system with origin at the crack tip. Origin at the crack tip. Hence, z should be replaced by z plus a. So this is mentioned clearly. This is a important uh, step. I mean, or important part, so that you can proceed very properly. So and then this is phi of z divided by square root of z. This stands to equation 2. Here phi of z is real and constant at origin. Okay, and sigma y tau xy are 0 at the crack surface, that is crack edges are stress free. That's what here it is shown, it is stress free. And next, k is for mode 1. This is for mode 1 is mode 1 crack. Okay, so this is a relevant relation. And next, consider this one, polar coordinate at the origin. Okay, from the origin, sorry. So z equal to r e to the power I theta, stresses at crack tip. Okay, so this is what you have to write. This is equation 4. And next is, yeah, and this is the equation for or relation for displacement of the origin of the coordinate system to the crack tip. Okay, we have to rewrite this equation 1, so that you will get equation 5. And after comparing equation 3 and 5, you will get this mode 1 crack. For mode 1 crack, sigma square root of pi into a, sigma y, because we have shown here we have shown it, sigma x is equal to sigma y is equal to sigma. Okay, here we have sigma y also, but here on the crack surface. Okay, here on the crack surface. Okay, when infinity, this will tend to sigma. So here this is v, and this is u. V is towards y and it is for x. So here lm and re, that is a real part and imaginary part. That is re is related to normal stress, and lm or im, whatever you can consider, that is for shear stress. Okay, lm or im on imaginary part and real part. Okay, so this is the equation. You can continue this one. And next is general solution. this is the one general solution you can write. Don't skip this step. All steps are important because I have made it brief. Lots of other theoretical parts are there, but in the examination or for the purpose of exam you do not need to write all those explanations. This much are sufficient for you to produce on your answer booklet. And similarly for mode 2 and mode 3 cracks, you have to follow the same procedure whatever you have done for mode 1 crack. So by that time for mode 2 crack, this is k11, that is it is not 11 but is mode 2, k2. And similarly for k3, these are the solution part of mode 2 and mode 3. Thank you.